All right, this is one of those problems that it's not hard, but there's just a lot of algebra to get to where you need to be. Okay, so let's see. I'm trying to figure out the power required. Okay, so I need power. So let's start with power is work divided by time. Okay, so how am I going to get power? So let's, so power is work over time. So I need some way to relate work and all this other stuff. Okay, so heat transfer, because this has to do with insulation, it gives you thermal conductivity, right? I know that thermal conductivity, delta Q over delta T, the rate that heat is transferred into or out of something, is equal to the conductivity times the area times the temperature difference, so hot minus cold, divided by the thickness. So what's what? 3 centimeters thick, that's my thickness, except I need to convert that to meters. 4 square meters, that's my area. Thermal conductivity, that's my K. Extracted, that's the coefficient of performance. I'm going to talk about that in a second. That's a coefficient. Temperature of the room is 24 degrees, temperature inside the refrigerator. So this is my hot temperature, and this is my cold temperature. Okay, so I've got all this stuff. Okay, so let's relate that to coefficient of performance. Coefficient of performance is basically the cold heat divided by the work. Right? So the other way you could write coefficient of performance, if I write this for work, so work would equal Q, what would be QC over the coefficient. I could also, instead of writing it like this, I can say work is QC times the temperature difference, so hot minus cold, divided by the coefficient times the cold temperature, right? So my coefficient, like mine is 7.5%. So for C, what I would put here is I would put 0.075, because you have to write a percent in terms of a decimal, right? So that would be C, right? Okay, so now I've got 3 equations. So let's write power in terms of all this mess. So power is work over time. Okay, so I know work is all this stuff. So work is QC times hot minus cold over coefficient times cold. So work over time, this is work, divide it by time. I'm going to put a denominator, I'm going to put a delta T in the denominator to make it work divided by time. So all this mess is work, and that's time, and that's equal to power. Okay, so that's equal to, power is work over time. But look, see how Q, this little part right here, this is where you're just doing algebra tricks, right? It's not really tricks, it's just algebra. But I'm going to take this, and I'm going to put it in for here, right? All this stuff is going to go in for that. So K times the area times hot minus cold divided by L times T hot minus T cold, right? That looks ugly. Over coefficient times T cold, right? So this is the stuff, I just swapped in this for that, right? Because I don't know Q and T, but I do know all this stuff, right? Okay, so now let's combine some stuff, right? So, well, I'm just going to multiply. That's the same thing, so it's going to square, right? So that's K times the area times hot minus cold quantity squared, right? Because that times that, divided by thickness times the coefficient times my cold temperature. And let's see if I know everything. K, area, hot, cold, L, coefficient, temperature, cold, yes. So there's what we're going to do, right? Just a convoluted way of getting it. There's what we're going to do. You just got to remember, convert centimeters to meters for your thickness, and this coefficient needs to be written as a percent, 2 decimals back.